This lesson is on solving linear inequalities. A good way to solve a linear inequality is through a process of graphing it. And the first step in that process is to graph the boundary line. Now, to make that graphing a little bit easier for me, I'm going to solve this inequality for y. So my first step is going to be to subtract 4x from both sides. That will give me negative 2y is greater than negative 4x plus 8. You might recall that subtracting does not change the direction of the inequality. My next step is to divide through by negative 2. Now, dividing by a negative number will change the direction of the inequality, so our greater than becomes a less than. These divide out to be 1y. Negative 4 divided by negative 2 will give me 2x, and 8 divided by negative 2 will give me negative 4. So, these two inequalities are equivalent. And this shows me that my boundary line would be the boundary line y equals 2x minus 4. Now, because that's in slope-intercept form, mx plus b form, it's showing me that my slope is 2, or the fraction 2 over 1, and my y-intercept is negative 4. So I begin graphing by placing the y-intercept on the y-axis at negative 4. Now, my slope of 2 tells me to go up 2 and right 1 from that point. And I can continue that pattern of going up 2 and right 1 for more and more points on my line. So this is tracing out my boundary line. But before I draw it in, I should decide whether it's dashed or solid. And I make that decision by looking at the inequality. My inequality is strictly less than. It doesn't have the equals with it. So what that's saying is that points on the boundary line, 2x minus 4, will not solve the inequality. So to show that I don't want to include points on the line, I make my line dashed. So the line that contains these points will be a dashed line. So my next decision will be to decide whether to shade above or below the line. Remember that the line was a dashed line through these points. Now, the inequality is less than, and that suggests I want to shade below the line. But to verify that decision, I should probably use a test point. And since 0, 0 does not lie on the boundary line, it's a great test point because it's real easy to plug zeros into the inequality. 0 is less than 2 times 0 minus 4. That gives me 0 is less than 0 minus 4, which gives me that 0 is less than negative 4. Now that is a false statement. 0 is not less than negative 4. So when the test point does not satisfy the inequality, what you want to do is shade the side of the line that does not contain the test point. So we do end up shading below the line here. Now what this shaded area is showing us is all the points that satisfy the inequality. There are several points that satisfy this inequality. I'm just going to mark a few in red. Now, because the line is dashed, the points that are on the line would not satisfy the inequality and would not be considered solutions. So just the shaded area is showing me this infinite number of solutions to my inequality.